Now we will discuss about the higher order constant coefficient ordinary differential equation, non-homogeneous ordinary differential equation, the various cases for non-homogeneous functions I have already discussed. Now we will teach, we study the functions, non-homogeneous functions which have not discussed, or the particular cases which are difficult to explain by that technique. So now today this is a special case. Now if the particular non-homogeneous function is like this, e to the power x, sec x, tan x, logarithmic function, etc. For these functions there is no proper rule. So this type of problem how can you solve? For this problem we will solve generally in a specific way. For all this problem we try to solve in that specific way. Now to discuss this, we consider a particular differential equation, say d square plus 3d plus 2 of y is equal to, say, e to the power x. So how can we solve this? First of all, we need to find the complementary function. Here 2, 3. So we know that the auxiliary equations is m square plus 3m plus 2m is equal to 0. This implies m is equal to minus 1 minus 2 minus 1 minus 2. So the complementary function, therefore the complementary function is c1 e to the power minus x plus c2 e to the power minus 2x. Now the particular integral. Now particular integral is equal to by d square plus 3d plus 2 e to the power x. e to the power x. This is equal to, this is e to the power x. So we need to solve all times its form is this function, this linear function. You have to factorize in the linear factor, first linear factor. Then we just write a by the first linear factor plus b by second linear factor, or other different linear factor we need to separate in this way. C by another linear factor, d by another linear factor. But here there is no linear factor. So now we need to find the value of a and b. We need to find the value of a and b. Here for this case the value of a and b are, we know the value are 1 and this is minus 1. Now we write this is equal to u of u minus v e to the power x. Say now, so u is equal to, now u is equal to d minus 1 e to the power x. So du minus u is equal to e to the power x, or we can, this is linear differential equation, so we can solve it easily. So the integrating factor of this integral equation is, sorry, d minus 1, d plus 1, d plus 1, d plus 1. So integrating factor is e to the power x. So we know that d of e to the power x u is equal to e to the power x, e to the power x, e to the power x. So integrating we get e to the power x is equal to integration e to the power x, e to the power x dx. So if we put e to the power x is equal to t, then it will be e to the power t into dt. So ultimately its solution will be e to the power t. So e to the power t means e to the power x, e to the power x. So u is equal to, this implies u is equal to e to the power minus x into e to the power x, e to the power minus x into e to the power x. So we get u is equal to e to the power minus x into e to the power x, e to the power x. Similarly, again v is equal to d plus 2. So dv plus 2v is equal to e to the power x. So now its integrating factor is e to the power 2x. So we get d of e to the power 2x into v is equal to e to the power 2x e to the power x. Now integrating we get v into e to the power 2x is equal to e to the power 2x e to the power x into dx. Now putting e to the power x is equal to t, we get, this is e to the power t, this is e to the power x is equal to t. So t into, it's here t square and here dt by t. So ultimately it will be t into e to the power t. So this is equal to t e to the power t is equal to e to the power x. So its integration is, the integration of this function is e to the power t minus 1. So this is putting e to the power x, e to the power x, e to the power x minus 1. So obviously v is equal to this is e to the power x into e to the power minus x minus e to the power minus 2x. Now here if we put that value of u and v in this equation, then we get ultimately the particular integral is equal to, this is positive, negative, one negative, negative, so ultimately negative. So this will be minus 2x e to the power x. So that the general solution is, therefore the general solution is c1 e to the power minus x plus c2 e to the power minus 2x plus e to the power minus 2x into e to the power x. This is the general solution of the given differential equation. So please.